Okay, so in this lesson, we're going to talk more about tables and graphs and this idea about functions that we were talking about last time. So let's just review a few of the concepts we've already covered, which is an ordered pair is in the form x, y, and remember the order is important. That's why we call it an ordered pair. And you can find ordered pairs listed in a table. We've seen that, a table of values, presented in a list. And that was kind of like your roster form. Remember the roster form? So it could look like 1, 2, 3, 4, etc. Okay, and we'll look at some examples of tables. You could also have a rule or an equation that would generate an infinite number of ordered pairs. And you could also see ordered pairs graphed on a Cartesian coordinate system. And that was what we were looking at last time on the graph. A relation is a set of ordered pairs, and then a function is a special kind of relation in which the ordered pairs would have no element of the domain is paired with more than one element of the range. So we say that x cannot repeat. Okay, so we have another way of testing that, and that's actually called the vertical line test. If a relation is a function, no vertical line passes through 2 or more points on the graph. And the reason why this is because all vertical lines have x repeating an infinite number of times. I'll show you what that looks like in just a moment. So let's first look at a couple of examples here. So example 1, is the relation a function? So if we look at the very first set of ordered pairs, and this is a list, we're using set notation, and this is a roster list because we're listing only 3 sets of ordered pairs. Would you say that this is a function or not? And a lot of you are saying yes. Why would you say that it is a function? Exactly, none of the x's are repeating. If we look at this set of ordered pairs, which is a relation, is it a function? And you said no, and what's the problem with it? Yes, x is 3 is repeating, and so that means if you ask the question, if x is 3, what's y? You get 2 different answers, and we don't have a way of proving which one is really the answer. So we say, well, since I can't discriminate against -3 or 5, I can't choose, I don't want to have a bias, then I have one question that has 2 separate answers, and that's dysfunctional. It's not a function. Okay, now if we look at this one right here, there are actually an infinite number of points on the line. You would not even be able to list all of these points, okay? But if I draw a vertical line, I'm not able to cross this line more than once. You see what I'm saying? With one vertical line. And that's because this vertical line happens to be x equals -2. Every single point on this line, if we start to draw some ordered pairs, this would be -2, 6. This would be -2, 4. This point right here would be -2, 0. And notice that all of the points on that line are going to have one thing in common, and that's that x is equal to -2. So is this line that has an infinite number of points, is this line a function? What do you say? It is, because none of the x values are going to repeat. And you could even, to prove that to yourself, you could start to identify, they gave you 2 ordered pairs, but you could identify 0, -3, maybe here is 4, 0. You could start to identify a few of the ordered pairs. Now, what about this one? If you were to draw a vertical line, could you cross this relation more than one time? You could. Okay, and I'm just going to draw this vertical line here just to prove I'm crossing at 5, 5, but then down here there's another point, and that x is going to repeat. So we have 5, -1, and the equation of that vertical line would be x equals 5. Anytime you have a vertical line, you can always name it x equals, and it's just that one value that it's crossing. Okay, and we can see that we are able to cross it twice. We're able to cross it twice here as well. Anybody have any thoughts about what the equation of that vertical line would be on the y-axis? Yes, x equals 0. And that line will have an infinite number of x coordinates equal to 0, but it's crossing the relation twice, which makes it not a function. So is it a function? No. All right, let's go on to a few more examples. So, example 2, given a relation, state the domain, state the range, and tell if it represents a function. So, the domain, can you remind me, what does the domain mean? Yeah, and so who can tell me what the domain is here? 6, 7, 8, 9, because you're taking those x values. What's the range? Yeah. I'm actually going to put them in order 10, 11, and 12. And remember, because 12 is the same number, it's repeating twice, but I only have to list it one time. So is this a function or not a function? Yes, it's a function. Good. We're getting really good at that. And you can say that's because none of the x values are repeating. So it's okay if the range has a smaller number of elements than the domain. As long as the x values do not repeat, the y values can repeat in a function. Okay, what's the domain for the next set of ordered pairs, the next relation? 6, 7, 9. And you're already seeing that 9 is repeating, okay? And what about the range? 10, 11, 12. And it doesn't matter that the 12 is repeating. Notice I'm having a hard time with my set notation as well. Is this count as a function or not? It's not a function. And why do you say it's not a function? What about it makes it not a function? Yeah, since the 9s are repeating, that question, what is 9, 11, what is 9, 12, means I have two different answers, so it can't be a function because the 9 is repeating. And by the way, if we were to plot all 4 of those points, what you would notice is 9, 11 and 9, 12 would stack above each other vertically. And so you would be able to draw a vertical line and cross through both of them. And that vertical line would be x equals 9. Okay, any questions before I turn the page? Okay, let's look at example 2 continued on the next page. Here we're seeing graphs and tables, and we can still identify the domain and the range and decide if it's a function. So for this table of values, what's the domain? -5, -3, 0, and 6. And then what's the range? 2 and 10. And is it a function? Yes. Any questions about that one? Okay, now your domain and range is going to get a little bit more complicated because here I only had exactly 4 ordered pairs. So again, if I were to graph this on a coordinate plane, I would literally only have 4 points. I would not be connecting the points. But for letter D, I actually have, could I list all of the domain, the x values? I couldn't. Why? Exactly. There's an infinite amount. Every single point on this line, which is an infinite number of points. So another way we could talk about the domain is we could use interval or set builder notation. I'm going to use interval notation because I feel like that's just a little bit easier. It's a little bit more concise. So my x values start at -8. Is that point -8, is it included or not included? It's included because it's filled in. So we have -8 is where it starts, and the arrow tells me it keeps going for infinity. So where does it actually stop? Positive infinity, and we don't include infinity since we actually can't include it because we can never get there. So that's where it stops, but that means it never stops. Okay, what about the range? The range is the y values. So think about the range is going up and down. The domain is going this way because that's my x values. Domain is this to this. And my range is going vertically. Okay? So what's the smallest value of the range? It's actually going down to negative infinity. So the starting place is negative infinity, and then you notice that the range is going up. The biggest value of the range is actually going to be 2, which is included. Because the range is going this way, and we are going to go small to large. We're always going to go bottom to top, and that negative, or that arrow is pointing down towards negative infinity. Does that make sense how I got that range? And so what I'm using here is interval notation. Okay, is this a function? How would we determine if it's a function? What do you think? We could use the vertical line test, right? Could I draw a vertical line and cross this line anywhere more than once? No. So would that make it a function? Yes. And we could say, yes, it passes the vertical line test. I just ran out of space, so I'm using an acronym. VLT, vertical line test. My dad actually loves to make acronyms out of everything. We had a cat, and he named it WK all the way, White Kitty. It was a white kitty. It was all white. So he's calling it a white kitty. WK. All right, anyway. All right, what's the domain here? You have arrows on the ends of that line. Yes, and we always go negative to positive, negative infinity to positive infinity. Okay, what about the range? Yes. I like to start with negative. It would look awkward to start with positive. It would be backwards because we always want to go smallest to largest. I prefer to go smallest to largest. I can't really say whether or not it would be considered wrong, but it would be weird and people would be like, what? Why are you going in that direction? So we just like to go small to large. Where does it start? Where does it end? What's the range? Same thing. Also negative infinity to positive infinity because we see those arrows on the ends. And is it a function? Yes, it is a function. Any questions about why that is? Okay, what about the domain for this? And by the way, does anybody know what the name of this shape is called, this graph? It's called a parabola, and it graphs what we call a quadratic. So we've been talking about linear equations, lines. So a linear equation is what we've been mostly focusing on in this class, but quadratics and parabolas are going to come up in Math 65, so I just thought I'd bring that up. Some of you might be familiar with it. What do you think the domain is here? It's going, I have arrows going in either direction, and this parabola is going to expand out as it goes down towards negative infinity, but my x values are starting at negative infinity, and the x values are going up to positive infinity. What about the range? Remember, the range is going vertical. So think about where it starts. What's the smallest number? And where does it stop, this parabola? It's very good. Negative infinity. It stops here because it comes up and then it goes back down. So the maximum point for the y is 6. Should we include that point? Yeah, it's included. Is this a function? Meaning, could I draw a vertical line and cross the function more than once? No. So it is a function. Since I can't cross the function or cross it more than once, and that makes it a function with a vertical line. Okay, let's look at this shape. And what do we call this shape? Does anybody know? Ellipse? Ellipsoid? Ellipse, yeah. Oh, ellipse. Okay, that's what I thought. I get that confused with ellipses. Ellipse, ellipses, two different things. All right, domain. What's the domain here? Starts and stops where? -4 to 8. Oops. Included, right? And then what about the range? Going bottom to top. Yes, 2 to 6. and I'm including both of those endpoints. That's why I have brackets around the ends. And then is it a function? No. And how come no? Yeah, the x's are repeating. If you can cross it with a vertical line more than once, it makes it not a function. It fails the vertical line test. Okay, what about here, the domain? This one's a little tricky because we have an open circle and a closed circle. So the open circle, what's the x value? It starts at -6. It goes until 8. Should I include that endpoint? I would say no, because it's an open circle. It means the endpoint is not included. And then here the endpoint is included, so I'm putting a bracket. What's the range? Who can tell me the range? You see where I'm getting those numbers? Should I include the -5? Should I include the 2? And is it a function? Yes, it's a function. Okay, any questions about that?